Hi, welcome to Join the Q-Rev, a job seeker's guide to the second quantum revolution. This masterclass is being brought to you by Qubo Consulting Corp. I'm AJ Sikora. I'm the co-founder and chief learning officer. And with me today is Dr. Katanya Kuntz. She is the other co-founder and the chief executive officer of Qubo. Today, we're going to take a look at quantum. In order for us to figure out what is quantum, we need to start with the definition. So what does quantum mean? That'll be our first section. Next, we'll dig into industry impacts, and we'll take a look at how quantum might impact these various industries. In section 3, we're going to talk about the quantum industry, both globally and here in Canada. In that section, we'll talk specifically to job seekers about what types of new roles might be opening up in the quantum industry. Then I'll pass it over to my co-founder, Katanya Kuntz, who will talk to you about the quantum basics. And she'll give you the technical definition of quantum, as well as some examples of quantum 2.0 technology. And then in the final section, Katanya will present a case study for optimization, and she will speak a little bit about what is quantum annealing and show a portfolio that is being optimized using quantum. So let's start off with section number 1. What does quantum mean? Let's take a look at the definition of quantum, why it could be disruptive, the areas to focus on, and the quantum threat. So what does quantum mean? I want you, the viewer, to think about this. What comes to mind when you hear the word quantum? Go ahead and shout it out. You can say it to your neighbor sitting next to you. What thoughts come to mind when you hear the word quantum? Excellent. I think everybody's had a chance to think about what this word means, and let's continue on. So, quantum physics is the study of the smallest particles that make up our universe. So how the universe behaves at the most fundamental level. So why could it be disruptive? Well, quantum matter behaves differently than things do in the classical world, the world that you and I live in. There are special properties that exist on this scale that can be harnessed and utilized to create new and improved technologies. So let's look at the areas of quantum technology. So there are commercial technologies being developed in computing. So there's quantum computing. Within quantum computing, we have optimization, which is one of the solutions being offered to businesses, and simulation, where computers can simulate various aspects of nature, let's say, using a computer system so that things like new drug discovery, new materials discovery could be done much more quickly. Then we have quantum communication. So quantum communication is a special technology because it offers a theoretically 100% secure channel for communicating. Then we have quantum sensing. Quantum sensors are more accurate and could be more precise than classical sensors. And then we're also going to talk briefly about quantum random number generators. So that means creating a truly random number using quantum technology. So let's talk about the quantum threat. I'm not sure how many of you have heard of the quantum threat. Raise your hand if you've heard of the quantum threat. All right. So quantum computing is expected to be exponentially more powerful than classical computers. So that means that some experts predict that it could break current encryption standards. In the next 5 to 15 years, when a fully functional quantum computer becomes available, it's expected that it could break some of our current encryption standards. So that creates an issue for people who have large data sets, sensitive data, or data that could be used against them. So if you had, say, healthcare data, you wouldn't want that information getting out. To complicate things of this quantum threat, there's this issue of harvest now, decrypt later. So what that refers to is that threat actors could be stealing encrypted data today and storing it until they have a quantum computer that is functional. Maybe that'll be 5 to 15 years for them to crack, but for some types of data, it's very important that it never gets into the wrong hands. That becomes an issue because the data could already be exposed today. And it's important for large organizations or people with big data sets to be aware of this threat. Next, let's look at the industry impacts. So we'll look at 3 industries: data security, manufacturing, and transportation, travel, and logistics. And as well, we're going to talk about the hype a little bit. So industry impacts. Can you guess which industries could be impacted by emerging disruptive quantum technology? I want you to turn to your partner next to you and I want you to say something to them. Just take a guess. What industries do you think will be impacted? I already gave you 3. Excellent. I'm sure everybody's had a chance to share now. So the first industry we're going to look at is data security. So data security is at risk because of the quantum threat. We wouldn't want any of our sensitive data to be accessed by a quantum computer. That means that there are big implications for companies that have that sensitive data. Like I mentioned, healthcare data is sensitive, maybe some financial information is sensitive even after a long time horizon. There's definitely government secrets, government communications that we would not want to be exposed at any point in the future. The one thing I wanted to point out here is the transition time. For large organizations, it takes them a long time to transition to a new technology. It might take years to figure out what type of technology to implement. Then it might take more years for them to transition that new technology. It's important for businesses and job seekers to become aware of this issue so that you can be a champion for quantum within your organization. Now, there are some solutions that are available. So as of right now, the US government and the Canadian government are pushing post-quantum cryptography. So post-quantum cryptography is referring to using more robust classical algorithms that are resistant to both classical computer as well as a quantum threat that could happen in the future. These algorithms are being developed and the US is planning to release some candidates of good, robust quantum algorithms. As well, there is a better form of communication called quantum key distribution. This is the form of quantum communication that is 100% theoretically secure. That one has a longer time horizon because there are a number of technological bottlenecks that will need to be resolved before we can get to the point where we can use that at scale. But that is a very good solution. I like the idea of 100% theoretically secure. The next industry we're going to look at is manufacturing. So quantum could be used to enhance the manufacturing industry in a couple of ways. First is the discovery of new materials. If a quantum system could simulate a natural environment, that would have far-reaching implications for the manufacturing industry, because what they'd be able to do is to test new materials for various properties in a virtual simulation rather than in the real world. So that would save a ton of money in research and development, as well as the time that it would take. So think about companies looking for new materials. Maybe they want something that has a specific tensile strength, or maybe they want it to have certain heat resistance. Then a quantum simulation could check those properties and test them in a simulated natural environment before they're ever tested in the real world. Another way that quantum could help the manufacturing industry is through optimization. So maybe operational efficiency could be improved in production, logistics, and supply chain. The final industry we will look at is the travel, transportation, and logistics industry. Quantum could be used in a few ways in this industry. First of all, I'm thinking fuel efficiency. It takes fuel to travel or to transport anything around this planet, and if we could do it more efficiently, that would save a lot of people a lot of money. Next would be route optimization. There are quantum systems that are capable of optimizing routes for maximum efficiency. And then as well, quantum could be used in safety and navigation. So maybe quantum sensors, which are more precise and more accurate, or could be more precise and more accurate than classical sensors, could be used in autonomous vehicles or for collision detection. The last part of this section is the hype. I want to make sure that everybody walks away with a clear understanding of quantum. First of all, quantum is not magical. It can't solve all of the world's problems. It's not a magic box that'll just spit out magical answers to everything. However, it is a real technology that is being commercialized as we speak, and new developments are being made all the time. Quantum does have a ton of potential, but we don't have a fault-tolerant or a fully functional quantum computer right now. The other thing to talk about with the hype is the timeline. Quantum is a deep technology. That means that a long time to commercialization. So some technologies are coming out now, typically in the quantum sensors market. Some forms of quantum computing are becoming available now, but a fault-tolerant, fully functional quantum computer is expected to be about 5 to 15 years away. I already mentioned that some of this technology is commercially available right now, and I also want to highlight there is a huge potential for disruption here. This is a big technological paradigm shift. This is not just the standard evolution in technology growth. This is more of a leap in technological growth, and it's got the potential to be very disruptive. It's really important to start preparing now. All right, let's look at section 3 next. This is the Canadian and the global quantum industry. In this section, I'm going to talk about investments. I will speak specifically to job seekers, and I'll let you know how you can start taking action. All right, so the quantum industry. I have another question for you. Which countries do you think invest the most in quantum technologies? Once again, I'd like you to turn to the person next to you, maybe turn to the other person next to you, don't give them the snub. Talk to them and tell them, what countries do you think are spending the most on quantum technologies? How high do you think Canada is on that list? Would you put Canada in the top 10, top 20, top 5? Okay, now that everybody has had a chance to share, let's move on. Here is some global investment dollars. This is from 2022. The global quantum investment, these are in US dollars. And let's see, China is the leader by far. 15 billion US dollars invested in the quantum industry in 2022, according to China. And the US is quite a ways behind. They're second in the world at $3 billion. Then at number 3, we have Germany. At number 4, France. Number 5, the UK. And look at that. Here we are. Canada is number 6 at just under $1 billion US dollars of investment. Let's look at the same data now in a graph form showing this as a percent of GDP. So however much money they invested, we've turned that into a percent of their gross domestic product. If we look at the chart here, Canada actually jumps up to the number 5 spot. The US drops way down. What are they? 1, 2, 3, 4, 5, 6, 7, 8, 9. They are 9th in the world. China still number 1, but Israel moves up to number 2. Some interesting data there for you to ponder. And now we're going to look at some of the notable investments in quantum. In 2022, the global investment in quantum reached $2.35 billion US. It dropped last year to $1.2 billion. But I don't think this is a reflection of the quantum industry specifically. I think it's more a reflection of the availability of capital worldwide and a trend that kind of happened in the investment market last year. This year, it looks like things are picking up already in the quantum industry, at least. The Australian government announced a few months ago that they were investing $600 million US dollars into one company called PsiQuantum, which is a quantum computing developer. They've bet a whole ton of money on one horse. They're hoping that this PsiQuantum is the company that builds the world's first fault-tolerant quantum computer. Some more notable investments from last year. So Quantinuum, which is based in the US, raised $300 million, which put them at a valuation of $5 billion. Pascal, which is a computing company out of France, raised 100 million euros, and that put them at a valuation of 409.7 million. And Photonic Inc., which is based in Vancouver here in Canada, they raised $100 million US. And finally, let's look at Sandbox AQ, which is actually a Google spinoff. They raised the most last year with 500 million US. As we mentioned previously, this year PsiQuantum already topped them with 600 million. All right, so now let's talk to job seekers specifically. There is going to be a massive demand for skilled workers in the quantum industry. By 2045, it is anticipated that the Canadian quantum industry will account for more than 200,000 jobs and be worth $139 billion. The federal government has already invested more than $1 billion in quantum in the last decade or so. In Canada, we have something called the National Quantum Strategy. The government has committed $360 million over 7 years to promote our quantum industry and to position ourselves to be a world leader in quantum tech. If we break down the National Quantum Strategy, it's got 3 pillars. The first one is the research pillar, and they're committing $141 million for basic and applied research to produce new solutions and innovations. Next, we have the talent pillar, which has $45 million committed to it to develop and retain quantum talent and also to attract quantum experts to Canada. And finally, we have the commercialization pillar, which has committed $169 million to it. And that's to turn research into products and services that will benefit not only Canadians, but citizens around the world. To fill the need for skilled workers to enter the quantum industry, right now we currently have PhD programs as well as master's level programs that are offered at many universities. Maybe in the future, post-secondary institutions will start to offer certificates as well. That's an area that we are interested in as quantum trainers with Qubo. As well, demand will be for the technical skilled workers to work on quantum technologies. As well, there's going to be demand for non-technical workers to join the quantum industry. That's something that not a lot of people think of. A lot of people think, hey, the quantum industry, that's so technical. I could never do that. But hey, maybe you're a human resources manager and you're looking to join a new industry. Guess what? The quantum industry is also going to need those people as well. Let's take a look at some examples of the different types of roles. This first page is all the technical roles. We have quantum hardware and software engineers, quantum algorithms developers, quantum systems architects, quantum security specialists. Remember I mentioned the quantum threat? Well, we need specialists to explain that to people and to help implement new systems to protect us. As well, we have quantum applications specialists, quantum metrologists. That's not like the kind of people who predict the weather. That's like metering technologies where people measure things. As well, we have policy analysts. With new technologies, we need new policies as well. And then, of course, we have quantum communications specialists. So those are just some examples of the technical roles. Don't take this as an all-inclusive list either. Now let's look at some non-technical roles that could be important for the quantum sector. Maybe business development managers, marketing and communications, sales. We'll need human resource managers, as I mentioned, project managers, product managers, customer service representatives. We'll need legal support, business analysts, as well as operations. So you can see all of the roles that exist in today's industries will also be important in the quantum industry. Let's take a look here at the quantum industry in Canada. This is from Quantum Industry Canada's website. Look, there's Qubo. We're down there in the bottom left of the top picture. And you can see that this is just Canada. There are a ton of players in the quantum industry here. All right, take action. This is what I want you to take away from this talk today. You don't need a PhD in quantum physics to get involved. Okay? Companies like Qubo Consulting Corp can act as translators to help explain it. What you should do is develop a general understanding of the implications of quantum. So the big general picture overview, why should people care? That's what you should figure out first. Start building quantum literacy now. Okay? Educate yourself to ease the transition. If you're looking for some trusted resources, you can look at the Quantum Insider, Quantum Industry Canada, IBM Qiskit. They have a free programming language that you can learn on their website. As well, I ask that you look for quantum job opportunities and research training programs to help get you there. All right, and as well, I'd like to mention that as Qubo Consulting Corp, we do offer quantum training. We're actually working really, really hard to make our courses available to you online. E-learning courses can be purchased directly on our website starting in the fall of 2024. As well, because you're a participant in the C Tribe X Tech Festival, you'll receive 50% off your first Qubo course. Email signup is required. So the next section, section 4, is going to be brought to you by Katanya Kuntz.
Wonderful. Thank you so much, AJ. So hello everyone, my name is Dr. Katanya Kuntz and I'm an experimental quantum physicist. And today I'll be talking with you about the quantum basics, as you can see here. We'll go through a technical definition of what is quantum, as well as examples of quantum 2.0 technology. Then I'll go into a case study called quantum optimization. This focuses on quantum annealing, so I'll define what that is, and also the financial portfolio case study. So first, we start with quantum basics. What is quantum? Quantum physics is the study of the microscopic, the submicroscopic, the atomic, and the subatomic, or elementary particles. It's all the matter, the stuff that makes up you and I, the universe that you can see around you. Quantum physics also explains how molecules are formed and how different chemical reactions work. So for example, you see here on the left, we have lots of different chemical bonds, different molecules. Quantum physics explains how these molecules form, how they operate, why they interact the way they do. The quantum world is also very different to our classical world. As you can see here with the chalk, this is actually a microscopic picture of chalk in the middle. And so a piece of chalk looks very different in our real world compared to this microscopic view. So that's just one of the examples of how different the quantum world is. We use mathematical models to describe our quantum world. These models have evolved over the century, over the decades, and as new theories develop from new experimental results. So there's experimental results where classical physics just couldn't explain it. The physics that we had for years and years could not explain these certain experimental results, and therefore new mathematical models were introduced, but they didn't fully explain the picture. For example, you might be familiar with this picture. It's the Rutherford model of the atom. It's one of those very common pictures of the atom where you have a nucleus in the middle and then you have the electrons spinning around the outside. However, that's not quite how it is. Our models have continued to evolve. You might have heard of the electron cloud model from Erwin Schrödinger. So that's evolved to the modern quantum mechanical model of the atom, which we use now. And now instead of the electron being seen as a particle, an indivisible particle, it is, but now it has this probability cloud, and it exists in these probability clouds instead of discrete orbits. These colorful pictures on the left here show you those probability clouds and all the different energy configurations it can take. Now, the modern electronics that we use every day, it's thanks to the quantum mechanics and understanding how atoms work, things like this. That is the quantum 1.0 revolution. So things like your TV, computers, LEDs, your cell phone, even the solar cells and electric cars. All of these electronics benefited from understanding how do atoms work, how do they interact with each other. We weren't addressing them on the individual atom level. It was just collections of atoms, collections of electrons. So then what is quantum 2.0 technologies? And what is this quantum 2.0 revolution? Well, AJ's done a fantastic job of introducing that to you already. And so these technologies use the properties of subatomic particles. And those are atoms, electrons, other particles, ions, for example. Also, you can use light in these applications to do tasks like quantum computing, quantum memories, communication, quantum random number generation, also quantum sensing. The list goes on, right? So why are all these modern electronic examples of quantum 1.0 tech and not 2.0? Again, it's because those were dealing with big signals, large sample sets, lots of atoms, macro states. So imagine this picture here representing a collection of atoms. Quantum 1.0 tech addresses all of these atoms all at once in an ensemble. Whereas quantum 2.0 technology, it's more about the individual atoms or individual particles of light called photons. So this is very different to our 1.0. And thanks to the differences of how classical physics and quantum physics work, we can harness some very interesting quantum properties. For example, it's possible to send information encoded in individual particles of light called photons. And this method of encryption is theoretically 100% secure, as long as that key that was generated between Alice and Bob, the sender and the receiver, was not intercepted or tampered with by an eavesdropper. And again, thanks to quantum physics having some different properties like the measurement disturbing the state, it's possible to know if there was a hacker that was trying to tamper with your key. So this is called quantum key distribution, and that's just a tiny little fast summary of it. If you want to learn more, we have courses about it offered with Qubo. So that was the basics, and now I'd like to talk about a case study, because I think it's really useful after we cover all these high-level concepts that we apply it to something that's applicable maybe in your everyday life, maybe it's something relatable to you. So that's what we try to do with all of our courses with Qubo. The quantum optimization case study, we're going to first define what is quantum annealing. So I have a reflection question. If anyone's ever heard of the traveling salesman problem, what comes to mind when you hear the term traveling salesman problem? I'm not sure if we're doing a live chat or anything like that, but put it in your answer in the live chat or write it down in your agenda. I'm not sure. I'll just give you another couple seconds. Have you ever heard of this? Okay, so quantum annealing is a form of quantum computing. There's various different ways, different platforms that you can do quantum computing, and these different platforms have different abilities. And so with the quantum annealer, this is a quantum system, and in this case, in this picture here, we're showing one of D-Wave's superconducting circuits. And so this quantum system, it's allowed to evolve over time, and as it evolves, it'll eventually go to its lowest energy state, because everything in the universe wants to be in its lowest energy state. Think of a ball rolling down a hill. Does it want to stay at the top? No, it wants to roll down to the bottom. In quantum annealing, this is a quantum process that finds the optimal solution to a problem by allowing a quantum system to evolve to, again, its lowest energy state, and that is the solution. These superconducting circuits, they have to be cooled to almost absolute zero degrees Kelvin to operate, just above. And so companies like 0 Point Cryogenics, which is in Edmonton, they build these cryogenic fridges, which you can see in the picture here with John and Chris. And these fridges can be used for all sorts of quantum 2.0 technologies, including quantum annealer. And by harnessing the bizarre quantum properties like quantum tunneling and superconductivity, we can do tasks like computing. So a quantum annealer processing unit, it's considering all these possibilities simultaneously as it finds the lowest energy state that's required to solve the relationship that you've fed into the system. These annealers are very applicable to problems that become exponentially harder to solve with every new parameter that's added. And for the techies that are listening right now, that's called the NP hard problems. So D-Wave, as I mentioned before, they're in Burnaby, BC. They make quantum annealers that can solve various optimization problems. And these types of problems range from balancing financial portfolios, solving transportation and logistics problems, new drug design, simulations, things like that. Also, energy distribution and management. And this is just a handful of the applications. Basically, anything that falls under what's called that traveling salesman problem, something that gets exponentially harder the more variables you add in. So let's take a look at a case study with D-Wave where they're optimizing a financial portfolio using quantum annealing. So when you're managing a diverse portfolio of financial assets, it usually requires a lot of computational power because, again, there's a lot of parameters. And in this case, we want to achieve the maximum reward with the lowest possible risk. For example, how complex can these problems get? So the number of possible configurations for a portfolio of just 8 assets with monthly transactions over 4 years is larger than the number of atoms in the known universe. So that is just ridiculously huge, impossible for our current computers to solve. Okay, so let's take a look at a financial portfolio case study with D-Wave. So Multiverse used a D-Wave hybrid solver, which combines a classical computer with a quantum solver, to develop an algorithm that rapidly generates optimized portfolios. This recent demonstration used real financial data in collaboration with 2 European banks. So the problem, identify management strategies that yield the highest Sharpe ratio. A Sharpe ratio is a metric that is reflecting of the rate of return at a given level of risk. So 8 is a virtually risk-free investment. Multiverse used several different platforms, quantum and classical, to find the optimal solution given different data sets from a very, very small XS to extra, extra large. They also worked with daily real financial data from 52 different assets over 8 years. So as you can see from these graphs, there were various different methods that they used, which is on, let's just look at this graph on the left first. So all of these classical methods, except for the D-Wave hybrid solver right there. Basically, the D-Wave hybrid solver only took 171 seconds for the extra large data set, whereas the best classical result, the one that could actually handle that size, was the tensor network, and it took over a day to run. And there were various other methods that wouldn't have even been able to solve that data set size. This is an example of how the quantum solver is able to optimize very large data sets and achieve problem solving much faster than the current classical solutions. And as for the Sharpe ratio, it was able to achieve a 12 versus a 15. Both are over 8. I believe that these are very viable solutions. Quantum optimization can also be applied to other areas like fraud detection and to produce early warning for impending market events. Well, thank you so much for watching. Again, my name is Katanya. AJ, we were so happy to be able to provide this recording for you. And thank you so much to the organizers and to C-Tribe and to SAR for inviting us. If you'd like to learn more, please check out our website, QuboQuantum.com. We're also on LinkedIn. Please feel free to link with us and reach out. And you lucky festival goers, you will receive 50% off your first course purchase. When you sign up, just send us an email and we will send you your discount code. So thank you so much and take care.